So we just learned what is geometric vector. So here's a question to represent the situation in the form of geometric vector. Question number 2. Draw geometric vector to represent each of the following situation. A. Weight of 50 newtons acting vertically downwards. B. Velocity of 80 kilometers per hour on a bearing of 250 degrees. C. Displacement of 30 kilometers northwest. D. Force of 60 newtons on north 40 degrees west. That much is enough, okay? Now, so these are your statements, and write them or represent them in as a geometric vector. So that's a problem for you. Now, here's an instruction. It says choose a convenient scale and use protractors. So that is for accuracy, right? So do this problem and then look into my suggestions. Now, whenever, as we said earlier, you want to represent a vector with geometric vector, then a line with initial and terminating point represents the magnitude. The arrowhead represents the direction. So those are two things. Now, length of the line is proportional to the magnitude, and therefore we need to make a scale, correct? So let me show you how. So I'm not really using a protractor and a scale. You do it when you do it, right? So I'm just showing you approximately how to get your answers, right? So as the first one says, weight of 50 newtons acting vertically downwards, right? So that means the magnitude is 50 newtons. So we can say first define your scales. Let me write for this. For every question there will be different scales, right? So we say scale, let's say 1 centimeter equals to 20 newtons. So this is very important to write. Scale 1 centimeter equals to 20 newtons, right? Vertically downwards, so these directions, whenever we're talking about directions, then we are referring to east, west, north, south, and so I'm just making general directions here for all of them. So we say the direction being followed is north is here, right? So even if we don't specify, it is taken by default as north in this. But somehow if you want to change the direction, then you have to specify, right? So for this purpose, let me first make my directions very clear. And that is these are my directions, correct? Now when I talk about 15 newtons, two things, and vertically downwards. So I've got the magnitude, which is 50 newtons, and direction, which is vertically downwards. Now my scale is 1 centimeter is 20 newtons. So 50 newtons will be, let us see like this. So let me draw it here. So from here, if I start from here, that is the tail, right? So let's say this is 1 centimeter, and then we have, that is 20 newtons. Then we have 2 centimeters, that's 40 newtons, and half. So we get 50 newtons. So I draw a vertical line from here, like this, right? And that gives me 50 newtons, correct? So I can write here 50. It's important, write it down. So you know that is the geometric representation. It tail, head, initial, terminal. Magnitude is represented here, 50 newtons. Direction going southwards. Do you see that? So that is how you are going to draw each one of them. And that is the real geometric vector representing the vector here in words. So this description is the vector in words. So next question will be to describe the vector in words where you need to use this kind of language. Velocity of 80 kilometers per hour on a bearing of 250 degrees, okay? So do that in the next one. So go through it carefully. Now second one is velocity of 80 kilometers per hour on the bearing of 250 degrees. Now, again, let's make a scale for this, right? So I'm just using the small space to do all the solutions. 80 kilometers. So we'll say, well, let the scale be of 40 for us, correct? So we do 40. Now, so wait a minute. So we'll do it later, right? Let's say we say again 1 centimeter. I'll write here scale 1 centimeter. Okay, I'll write scale on this side. 1 centimeter equals to, let us say, 40 newtons or 40 kilometers per hour. So that is part B. So 1 centimeter is 40 kilometers per hour and the bearing angle is 250 degrees. So what is the meaning of 250 degrees? 250 degrees means from north it is 250 degrees, correct? So we know this is 270, so 20 less. So that becomes the direction. Do you see that? So that is from north, that much angle is actually 250 degrees. So we get the direction and the velocity is 80 kilometers. Now use your scale of 1 centimeter and 2 units. So 1 centimeter, let's say this is my 1 centimeter, right? And then another centimeter. So these are my 2 centimeters, which will give me 80 kilometers. Now I can join this line here. So that's the initial position, terminating position, and I get 80 kilometers per hour. Magnitude and direction was just shown here, 250 degrees bearing, right? So that represents velocity of 80 kilometers per hour on a bearing of 250. Now displacement of 30 kilometers northwest. So let's say this is my scale for displacement. Now we say 30 kilometers. So let me have this time units of 1 centimeter as 10 kilometers, let us say. So each is 10 kilometers. How I define my scale? Each is 10 kilometers. Northwest. That means this is north and this is west, right? So northwest is 45 degrees going in this. So every centimeter is 10 units, therefore 30 will be 3 units. So we go here 1 unit, 2 unit and 3 unit, right? And we can join them with a scale, a perfect line, and say, well, this is my 30 kilometers. And then we write here 30 kilometers, 30 kilometers. And the direction is northwest. To be specific, we could write 45 degrees here, just to be specific that this is 45 degrees. That means northwest. Correct? So that's how we give displacement of 30 kilometers northwest. Important thing, as you see, is to mention scale, right? Scale. Last, force of 60 newtons on north 40 degrees west. So it is 40 degrees north from west, right? So let's make this here. So again, north is always here, so we'll just mention west, east and south. 60 degrees north. So let's choose a scale and say, well, every unit here is 20 for us. Let's say 1 centimeter is 20 units. So it's 20, 40, like that, correct? 40 degrees. So use your protractor and then make an angle of 40 degrees. So let's say this is my angle of 40 degrees. So I just join a line like this. So that is 40 degrees, correct? So that gives me the angle north 40 degrees from west. Now put your scale and each centimeter is 20 units. So we got to go 3 centimeters. Let's say this is 1 centimeter, 2 centimeters, 3 centimeters. So draw an arrowhead here and join your line. And then write down 60 newtons. So that becomes a force of 60 newtons on north 40 degrees from west. So that is how you are going to represent vectors as geometric vectors, correct? Two important things to remember here is always choose a scale and a protector so that you can accurately show your results, correct? So I've just shown you a rough sketch here. Sometimes in problem solving, rough sketch will do. But if the problem is only to represent geometric vectors and that's the problem, you have to be very accurate. Okay? Thanks and all the best.